So we know the base of one of those triangles. We know that the surface area of all the triangles, or the lateral area, is 3,000. And we want to find the height of the model. So in other words, how much it is here, straight down. That looks straight. That looks straighter. Straight down to the center. Okay? Does it make sense that if we looked at one of these triangles, that we could figure out the area of one of the triangles? Just take the 3,000 and divide it by 4. So if I do that, if I take my 3,000 and divide by 4, (750 inches squared) will be the area of one triangular face. We know that the side length of that triangular base is 50. And we're sort of working backwards from what we had before. If I know the area of the triangle and I know the base, what can I find out about that triangle? If I look at my formula, I know the area, I know the base. The only thing in this formula that I wouldn't know then is the height. So if I put in all the numbers, I can use my algebraic skills and figure out what the height is. So putting in all those numbers, I know the area is 750. I know my base is 50. I don't know my height. Divided by 2. And a little bit of algebra here. 50 divided by 2 is 25. If I want to get h by itself, I would need to divide both sides by 25. And I get a height of 30. Does that tell me the height of the whole model? Or it just tells me the slant height. So now I know the slant height. If I go back to our original diagram here, I have just figured out that this height here is 30. Using that red line and the blue one, can you in 2 dimensions, so the blue one was 30. We want to find the height, so I'll leave that as h. How long is that black line? 25. Because that's going to be half of the square side length, which was 50. So now, with that picture there, go down here, I know that a squared, which plus b squared, equals c squared. 30 was the hypotenuse, so that goes by itself on one side. If I multiply these things out, 25 squared is 625. 30 squared is 900. Subtract 625 on both sides. And square root that. 16.58. Question said to the nearest tenth of an inch. So the height is approximately 16.6 inches.